Shortest distance between two parallel planes. In the example above, we saw that part A gave us a positive value for D and that part B gave us a negative value for D. We ignored the negative when giving the answer for the distance. There is, however, a significance to the sign of D. The fact that one was negative and one was positive meant that the two planes were on opposite sides of the origin. If the signs had been the same, either both positive or both negative, then the planes would have been on the same side of the origin. We can use the distances of two parallel planes from the origin to calculate the distance between them. So in the first diagram here, the origin is down here, so the two planes are on the same side of the origin. We can see we have a plane pi1 and the distance is d1, and a plane pi2 with a distance of d2. In the diagram, we can see two parallel planes that are on the same side of the origin. D1 is the distance of plane pi1 from the origin, and D2 is the distance of plane pi2 from the origin. It should be clear that the distance between the planes is the modulus of D2 take away D1, or just D2 take away D1 if they're both positive and D2 is the longer distance. But if you do mod D2 take away D1, you can't actually go wrong. In the second diagram, we have planes where the origin is here and we're on opposite sides. Again, the distance D1 is here and the distance D2 is here. One would be positive, one would be negative. If the points D1 and D2 are on opposite sides of the origin, then one of them is positive and the other one is negative. The distance between the planes will still be given by mod D2 take away D1.